Welcome to Farming 2025. Tech and Green Shift. In this talk, we'll explore how technology and ecological practices are rewriting the rules of agriculture. Over the next slides, I'll guide you through data-driven farming, gene-edited crops, soil restoration, new service models, and urban growing systems, all aimed at producing more with less while restoring the planet. This slide shows how precision agriculture turns data into action. Satellites, soil probes, drones, and micro-condition maps feed AI analytics that generate irrigation, nutrient and spray prescriptions for each square meter. By matching inputs to exact needs, farms can cut water, fertilizer, and pesticide use, lower costs, and reliably lift productivity towards sustainable, high-yield outcomes. Gene editing with CRISPR is accelerating breeding and boosting crop resilience in targeted ways. By improving heat, drought, and pest resistance, these non-transgenic edits can raise yields by up to about 25% without extra inputs. Faster, precise breeding cycles also allow crops to adapt to shifting weather and market demands, while reducing chemical dependency over time. The green shift is about repairing ecosystems and creating value from healthy soil. Practices like no-till, cover crops and crop rotation rebuild soil biology, improve water retention, and boost biodiversity, while verified carbon sequestration can create new revenue streams. Combining ecological repair with market incentives helps farms become more resilient, profitable, and climate-friendly. AgriTars replaces high upfront capital with pay-UPUs access to robotics, analytics, and satellite advice, letting farmers subscribe to services instead of buying expensive equipment. This model lowers barriers, accelerates adoption across different farm sizes, and narrows the technology gap, enabling more equitable access to advanced tools without crippling capital strain. Autonomous systems collect continuous field data, solar drones, map weeds, pests, and growth stages in real time and stream that into AI models. Those models produce precise prescriptions that drive spot spraying and nutrient bursts, cutting manual labor, chemical use, and energy consumption, while extending management precision from occasional checks to hourly, crop-level decisions. Urban vertical farming brings stacked hydroponic towers into city centers for consistent year-round production using about 95% less water and no pesticides. Locating production near consumers slashes transport emissions and food waste, while controlled environments deliver consistent quality and resilience to climate extremes, turning buildings into reliable local food hubs. Mainstreaming alternative proteins is fueled by consumer demand and policy, and enabled by technologies like precision fermentation and scalable bioreactors. As capital flows into these platforms, the result is reduced land use and methane emissions, plus new market opportunities. That transition also opens diversified income streams for farmers and strengthens food system resilience. Digital adoption faces real barriers in places like sub-Saharan Africa. Slow connectivity, skill shortages, and data privacy fears leave roughly 70% of growers without digital aids. Bridging that gap requires targeted training, affordable sensors, and robust data governance, so tools are usable and trusted. Solving these challenges is essential to empower all growers in an inclusive agricultural revolution. The 2025 agricultural revolution is an essential paradigm shift that integrates AI, advanced gene editing, and regenerative practices to produce more with less and restore the planet. Success depends on stakeholder alignment, policymakers, educators, industry, and farmers to align incentives, build skills, and invest in infrastructure, so every farm can make the sustainable, tech-powered leap.